In this video, I'm going to show you an example of the product rule for derivatives. I'm also going to show you an example of the quotient rule for derivatives. And we'll start with the product rule, which I have stated here at the top of the screen. And to illustrate the product rule for derivatives, we'll use this example here, which is y equals 5x squared plus 3 times the quantity 3x minus 2. This is a great example to illustrate the product rule because it is the product or multiplication of two expressions. So we'll start out by calling this first expression u, and we'll call the second expression v. And notice that the formula for the product rule will call us to utilize the derivatives for both u and v. So let's go ahead and find the derivative of u using the power rule. The derivative of u would be 10x, and the derivative of v, also based on the power rule, would be 3. Now we have everything that we need to apply the product rule. It's just a matter of slotting each piece in according to the formula. So the derivative of y would be equal to the expression u, 5x squared plus 3, times the derivative of v, which is 3, plus the expression for v, which is 3x minus 2, times the derivative of u, which is 10x. So once we identify u and v and find the derivative of each of those pieces, putting the expressions into the product rule formula is pretty straightforward, and this expression that we have here represents the derivative of y. The only thing that you might do to finish the problem would be to simplify this guy, and to do that you would distribute the 3 and then distribute the 10x, and then finally you would combine like terms. And I feel fairly confident in your ability to do that at this point, so I will leave the simplifying for this example to you. But as we move on to the quotient rule, I will include the simplification steps on this guy so that you can see that applying the rule is one thing and simplifying it can be quite the other thing. It can be kind of tedious and challenging, as we'll see here, but it's not too bad. Just bear with me, we'll get through this. So I have the quotient rule here at the top of the screen, and as you can see, it's very similar to the product rule, and the process for applying the quotient rule is very similar. We have an example here that I'll use to show you the quotient rule. It is y equals 8x plus 3 all over the square root of x. And I'm going to start the process very similarly. I'm going to let the numerator here be equal to u, and the denominator, I'm going to let that be equal to v, and then I'm going to find the derivative of each of those pieces. So the derivative of u, based on the power rule, would be 8, and the derivative of v, also based on the power rule, would be, and let's just go off to the side here, and v is equal to the square root of x. And recall that we can rewrite this as an expression with an exponent by writing the radicand of x, and then the exponent is equal to the power divided by the root. So 1/2 would be the exponent. And then by the power rule, to find the derivative of v, we'll bring the exponent down in front and then decrease that exponent by 1, which would give us an exponent of negative 1/2. And just so we're not staring at a negative exponent for this whole process, let's rewrite this as 1 over 2 square root of x. Okay, now that we've identified u and v and found the derivatives of u and v, now it's just a matter of slotting those pieces into the quotient rule formula. Let's see if I can move this down here just a tiny bit so I can see everything here on the screen. So the derivative of y is equal to the expression for v, which is the square root of x, times the derivative of u, which is 8, minus the expression for u, which is 8x plus 3, times the derivative of v, which is 1 over 2 square root of x, And then this whole thing is divided by the expression of v squared. So in this case, v is equal to the square root of x, and we'll simply square that. So here is the derivative of y. As it stands, it's awesome. This represents the derivative of y. But in some cases, you may be asked to simplify this further. So let's go ahead and go through all of those steps to get this thing fully simplified. I will make one note at this point, and that note is when you subtract the family of u times the derivative of v, you're subtracting that whole thing together as a family. And so we want to make sure to distribute this negative appropriately. And I'll show you how we do that here in just 1 second. All right, so let's go moving this to the top of the screen. And let's get to work here. Okay, let's start with the easy guy. 8 times the square root of x is just 8 square root of x. All right, so that wasn't too bad. Now let's distribute the 1 over 2 square root of x. So I'm going to distribute that. And I'm going to keep the brackets around this so that we, again, remember to distribute that negative properly. So we have 8x over 2 square root of x. And then when we distribute the 1 over 2 square root of x to the 3, we get plus 3 over 2 square root of x. And then this is all divided by the square root of x squared, which is equal to simply x. Now we need to distribute this negative. So we will rewrite this as 8 square root of x minus 8x all over 2 square root of x minus 3 all over 2 square root of x. And again, this is all divided by x. All right. Give myself some more room here. Okay, now notice that in our numerator, these two terms both have a denominator of 2 square root of x. If we can get this first term to also have a denominator of 2 square root of x, then we can combine all 3 terms in the numerator together. So let's go off to the margin here and recall some algebra so that we can make this happen. So we can rewrite 8 square root of x as 8 square root of x over 1. Then we can multiply the numerator and denominator of this fraction by 2 square root of x to get a denominator of 2 square root of x. Remember, as long as you multiply the numerator and denominator by the same thing, this is totally legit. So when we do that, we end up with 16x in the numerator. The square root of x times the square root of x is equal to x. And in the denominator, we are left with 2 square root of x, which is exactly what we wanted. Now, let's go back here to the problem and see how this is going to help us. So that first term, we will now write as 16x over 2 square root of x. And then I'll just finish writing out this numerator, 8x over 2 square root of x minus 3 over 2 square root of x. And remember, this is all divided by x. It can be easy to forget a little detail like that, so I do recommend that you write it out with each step so that you're sure not to forget it in your final answer. After all this work, we certainly wouldn't want to forget something as simple as just an x and get an incorrect answer. So continuing on, we can now combine these 3 terms in the numerator together. Notice that the first 2 numerators are like terms, 16x minus 8x, which leaves us with 8x. And we would then have a minus 3 in the numerator, which we can't combine because those are not like terms. And then this is all over 2 square root of x. And then remember, that whole thing is over x. And we're almost there. Bear with me, we are almost there. Okay, now we've got 8x minus 3 over 2 square root of x, all divided by x, which we can rewrite as 8x minus 3 over 2 square root of x divided by x over 1. And then to divide with fractions, remember we multiplied by the reciprocal. So we can change this to 8x minus 3 all over 2 square root of x times 1 over x, and that gives us an answer of 8x minus 3 over 2x square root of x. And believe it or not, that is your final simplified answer. So the derivative of our function is 8x minus 3 all over 2x square root of x. And just so you know, the reason that I wrote the denominator the way that I did, we have 2 square root of x times x. And notice that I stuck that x in front of the radical. That's just to eliminate any confusion about what's underneath the radical. So if we had written it as we may have wanted to here, I'll just go off to the margin. If we would have written this as 2 square root of x times x, then it could be confused what's under the radical. So that's why we just stick that guy in front so that there's absolutely no confusion. So I hope this video was helpful. I can't imagine how else you would have rather spent the last 10 minutes of your life, but I do hope that this example was helpful.